now we will see the limit of a function. So we will have to find the limits of some functions, some x tends to a. We are familiar with the limit. Okay. So but here we have to take the definition of the epsilon delta definition, actual definition of the definition of the limit. So in the last year or in the previous year, you have seen how to value the limit, the continuity of the function, derivative. Okay, so all the things you have seen this. Okay, so but here we have to see the particular definition of the limit. So that is called epsilon delta definition of a limit. So with the help of the epsilon delta definition of the limit, so we have to solve some problems. We have to show that limit is this. Okay, so for example, what? So limit what? X tends to a, x is equal to a. So we have taken this limit x tends to a is equal to, but we have to prove this. We have to prove this. So such a proofs we are not familiar with such a proof now. Okay, so now we have to prove this limit x tends to x, x tends to a, x is equal to a. So with the help of this epsilon delta definition, so we will see what is the epsilon delta definition of the limit now. Okay, so suppose f is a real valued function. Suppose f is real valued function defined on a subset of R. So a is a subset of a. That means f is a real valued function defined on a set a, which is a subset of the set of the real number. So this a is a cluster point. So last time we have seen the definition of the cluster point. So a is the cluster point of the a. Then the real number n belongs to R. That means the real number n. It's called a limit of the function f of x at x is equal to a. If this is very important now here. Okay, so this part is very important. Okay, for given epsilon greater than 0, there exists delta greater than 0 such that mod of x minus a less than delta implies that mod of f of x minus l less than epsilon. So this is the definition. So whenever your x minus a is less than delta, then your f of x minus l is less than epsilon. So if such delta exists, then we are saying that limit x tends to a, f of x is equal to l. So we say that the limit is exist and that is the l. Okay. So if you want to prove this what l, so you have to prove this delta is exist. You have to prove delta. So epsilon is given to you. That means this part is given to you. F of x minus l is less than epsilon. We want to show that there exists a delta greater than 0 such that this is less than 0. Then this f of x minus l is less than epsilon. So now we have to see the definition once again. Let f be the real valued function defined on a set A, which is the subset of R, and let A be the cluster point of A. Then L is the limit of f of x at x is equal to A. If for given epsilon greater than 0, there exists delta greater than 0 such that 0 less than mod of x minus l less than delta implies that mod of f of x minus l less than epsilon. We write this as limit x tends to a, f of x. We are familiar with this. Limit x tends to a, f of x is equal to l. Okay? So now we'll see the theorem now. So if a limit is exist, then it is unique. This theorem tells you that if a limit is exist, then it is unique. Okay? So what is the theorem? If f from a to r, that means it is a real valued function. C the cluster point of a, then f of x has only one limit at x is equal to c. Or show that it cannot have the more than one limit. Or so if a limit is exist, then it is unique. So all the three are the same here. So we'll see the solution or proof. So proof. Let L1 and L2 be the limits of, if possible, limits of f of x at x is equal to c. At x is equal to c. So therefore what? Limit x tends to c, f of x is equal to L1, and limit x tends to c, f of x is equal to L2. Okay. So now we will apply the epsilon delta. What we have to prove? What is our aim? Our aim to prove that L1 is same as L2. This is our aim. Okay. So what we have to prove? L1 is same as L2. Okay. So we will apply the definition of the limit now. Okay. So for given epsilon greater than 0, there exists delta 1 greater than 0, delta 2 greater than 0, such that Because what L1 and L2, for L1 delta 1 is delta 1 we are taking, for L2 we are taking delta 1. So this delta 1 and delta 2 we have to take, because we are assuming that this L1 and L2 are not same now. Okay, such that 0 less than x minus c. This is what c. X tends to c. So this is c less than delta 1, implies that mod of f of x minus L1 is less than, we will take epsilon by 2. Epsilon and epsilon by 2 are almost same, because epsilon is very small. Okay, so that means epsilon and epsilon by 2 are almost same. So we may take epsilon, no problem for this one. Mod of x minus c less than delta 2 implies that mod of f of x minus L2 less than epsilon by 2. So we take this. Okay. Now I will take this delta is the minimum of delta 1 and delta 2. So I replace here delta 1 as delta and delta 2 as a delta. Both 1 and 2 are whole. For this delta, both 1 and 2, both 1 and 2 hold. Both 1 and 2 hold. Okay, so that means what? Mod of x minus c less than delta. Delta is what? The minimum of delta. Less than delta, it is obviously less than delta 1. So if you replace here delta 2 as a delta, so that delta is also less than delta 2. So no problem for this one. So both 1 and 2 are hold for this delta. That means you may replace delta 1 delta 2 as a delta now. Okay. So what we have to prove? L1 minus L2. What we have to prove? Whenever this is your x minus c is less than delta, what we have to prove? L1 minus L2. L1 minus L2 is less than epsilon. Okay, so that means epsilon and epsilon is arbitrary. So you may say this is what? L1 minus L2 is 0 now. Okay. So I start from L1 minus L2. L1 minus L2. How I can write this in terms of f of x minus L1 and L2 that I want. Okay, so I can write this as f of x minus L2 minus f of x minus L1. Now see, if you simplify this, we might get L1 minus L2. So this f of x get cancelled. This L2 is minus now. This minus become plus, so L1. So this is L1 minus L2 in terms of f of x. Okay. Now this is what you can apply the triangle inequality. So you know that mod of x minus y is less than or equal to mod x plus mod y. Whatever this sign, this is plus or minus. So mod x plus mod y. Here not minus now. Okay. So here there may be minus or plus, doesn't matter. Mod of x plus or minus y is less than or equal to mod x plus mod y. So that we have seen. So we'll apply that property here. This is less than or equal to mod of f of x minus L1 plus mod of f of x minus L2. Okay. So now this mod of f of x minus L1, this is less than epsilon by 2. This is less than epsilon 2 whenever. So 0 less than mod of x minus c less than delta. Right? So therefore 0 less than mod of x minus c less than delta implies that L1 minus L2 is less than epsilon. Okay. So epsilon is arbitrary. Therefore L1 minus L2 is equal to 0. Therefore L1 is equal to L2. Okay. So now our theorem is over here. Okay. So theorem or whatever is, it is over. Okay. So we have shown that if a limit is exist, then it is unique. If a limit is exist, then it is unique. That we have proved now. Okay. So now what we'll do, using this definition of, this is called epsilon delta definition of the limit. This is called epsilon delta definition of the limit. And with the help of the epsilon delta definition of a limit, we have proved that if a limit is exist, then it is unique. Okay. Now we'll solve some problems. We'll show that limit. So you know that this is what limit x tends to 3. So this is what x plus 2 upon x minus 3, x plus 3. This is what you are taking. This is 5 by 6 now. This is what. But we'll prove this. using epsilon delta definition. So we have to prove this. This is same as this limit is same as 5/6. Okay. So this is the power of that epsilon delta definition. So what we did only this. This part is not did we did only the evaluate the limit of the function. So here what we have to prove. So that limit is what 5/6. We have taken that 5/6. But now here what we have to prove this. Okay, and that is the power of the epsilon delta definition. With the help of the epsilon delta definition, we can prove this limit of this x plus 2 upon x plus 3 as x tends to 3 is 5/6. Okay. Now we'll do this. We'll take a problem. So using epsilon delta definition, show that prove that by using epsilon delta definition of limit x tends to c, a is equal to a. That means limit of constant is constant. That you have to prove. Okay. Solution. We want to prove limit x tends to c to a. Okay. That is we want to show that there exists delta for given epsilon greater than 0, there exists delta greater than 0 such that 0 less than mod of x minus c less than delta implies that mod of f of x minus a is less than epsilon. This you have to prove. Epsilon is given to you. You want to prove that this delta is exist. You want to prove. That means what? We have to take this f of x minus a less than epsilon. With the help of this one, we have to prove that x minus c is less than some epsilon. Okay, some number. Okay, so that you have to prove. Okay, so f of x minus a is equal to a minus a. Okay, so because here f of x not here, we want to show that. So here we want to prove this. Here f of x is equal to a now. Okay, f of x is a. Okay, so a minus a, this is what? 0. This is 0. Okay, so that means what? You may take this is what? You may take this as this is 0. So you do not get here what? C now. You do not get here C. So therefore what? You may take delta is equal to epsilon. For every delta, this is exist now, right? For every delta, this is exist. So therefore what? Delta is equal to this 0 mod of x minus c less than delta implies that f of x minus a is less than epsilon. So therefore limit x tends to c a is equal to a. Okay. So we'll take the next one now. So you will understand that for next problem. Okay. Next, limit x tends to c. X is equal to c. Okay. Solution. We want to show that limit x tends to c, x is equal to c. So here f of x is equal to x now. Okay. So that is we want to show that for given epsilon greater than 0, there exists delta greater than 0 such that 0 less than mod of x minus c less than delta implies that mod of f of x minus c, your limit is c now, is less than epsilon. This you want to prove. Okay, so we'll take f of x minus c now. F of x minus c. So what is f of x? That is x minus c. That is x minus c. We get x minus c now here. Okay, so this is less than epsilon. This is less than epsilon because what we are taking f of x minus c. That is less than epsilon is given to you. Okay, so this is, so therefore what? So delta is equal to epsilon. That means delta is exist, and that is what your epsilon. So epsilon is given now. Okay, see that means what? You are able to find delta in terms of epsilon. You are able to find delta in terms of epsilon. Okay, so that is what, right? So delta is exist. So therefore there exists delta greater than 0 such that mod of x minus c less than delta implies that mod of f of x minus c is less than epsilon. So therefore limit x tends to c, x is equal to c. So this is x. This is x. Okay. Okay, we'll take another problem so that you will understand this now. Using prove that by using epsilon delta definition of limit. Epsilon delta definition. Limit x tends to c. Limit x tends to c. X square is equal to c square. Okay. Okay. Solution. See, this is obvious now. If it is not 0 by 0 form, we are putting x is equal to c square. So this is c square. This is obvious, but we have to prove this one. Okay, solution. We want to prove that. We want to prove that limit x tends to c, x square is equal to c square. So here f of x is what? X square. Okay. So that is we want to show that. We want to prove that or show that for given, so epsilon is provided to, for given epsilon greater than 0, there exists delta greater than 0 such that 0 less than mod of x minus c less than delta implies that mod of f of x minus c square is the limit is less than epsilon. So you want to prove that this delta is exist. This delta is exist. So this you want to prove. Okay. So now we'll assume this. Assume that mod of x minus c is less than 1. Is less than 1. Then is less than 1. So we know that mod of x minus mod of x minus c is less than mod x plus mod c. Mod x plus mod c. So therefore mod of x plus c, mod of x is less than or equal to mod c plus 1. Mod c plus 1. Okay. Okay, so we'll keep this as it is now. Okay, so now we'll take this what? F of x minus c square. So this is what? X square minus c square. Okay, so this is nothing but mod of x plus c into x minus c. We got x minus c here. We got x minus c here. Okay, so now here what? Directly we can write this. Okay, if mod of x minus c is less than 1, then mod of x is less than mod of c plus 1. Directly we can write this. Okay, if mod of x minus c is less than 1, then this is obvious now. Okay, so this is obvious. So now what we'll do? So here you got x minus c. We'll keep this at it. Well, you have to remove this is nothing but mod of x plus c mod of x minus c. So this is less than epsilon, so that we have. Okay, so before that what we will see, mod of x plus c. So mod of x plus c, see mod of x plus c, this is less than equal to mod x plus mod c. Okay, phi triangle inequality, this is less than or equal to, so this is less than or equal to, this is or strictly less than or equal to or less than equal to, doesn't matter, this is what then. Okay, so this is what mod of x plus c, this is what 2 mod of c plus 1 now, 2 mod of c plus 1. Okay, so I will therefore what, mod of x plus c into mod of x minus c is less than or equal to, we have to write a bracket plus 1 into mod of x minus c. Okay, just we have multiplied, this. Okay, now this is what, this is therefore what is this, this is your f of x, mod of f of x minus c square. Now this is your f of x minus c square, this is less than or equal to, this is less than equal to 2 mod of c plus 1 into mod of x minus c, and this is less than epsilon, and this is less than epsilon. So therefore mod of x minus c is less than epsilon upon 2 mod c plus 1, 2 mod c. So here we have taken this mod of x minus c is equal to less than or equal to 1, and here you got mod of x minus c is less than epsilon upon 2. That means what, there exists delta, right? So we got delta. So therefore what, let delta is equal to minimum of, so minimum of 1 epsilon upon 2 mod of c plus 1. Okay, so therefore what, so we have proved that there exists delta. So thus for given epsilon greater than 0, there exists delta greater than 0, such that we have proved that there exists delta greater than 0, such that mod of f of 0 less than mod of x minus c less than delta implies that mod of c square is less than epsilon. So therefore limit x tends to c, x square is equal to c square. Okay, so we are through now, we are through. Okay, so next we will prove, we'll take a number of problems so that you will understand this, the definition of epsilon delta, definition of the limit. So limit x tends to c, 1 upon x is equal to 1 upon c. So this we have to prove. Okay, solution. We want to prove that limit x tends to c, 1 upon x is equal to 1 upon c. Right? So here f of x is what? F of x is equal to 1 upon x. That is, we want to prove that for given, so epsilon is provided to, for given epsilon greater than 0, there exists delta greater than 0, such that 0 less than mod of x minus c less than delta implies that mod of f of x minus 1 upon c is less than epsilon. Okay, so this we have to do. Okay, now we have to take f of x minus 1 upon c less than. So what we do? Okay, so let mod of x minus c is less than c by 2. We'll assume this. This is what? C by 2. C by 2. Then we know that minus c by 2 is less than x minus c is less than c now. Is less than c by 2. Is less than c by 2. Okay, so we'll add c now. So c plus c by 2 You have to add this. Okay, c minus c by 2 is less than x, c plus c by 2. So this is what twice c minus c is again c by 2 is less than x, less than 3c by 2. Okay, so then we'll take a reciprocal of that one. So what we get then, 2 by c is greater than x is greater than 2 upon 3c. That is what, 2 upon 3c is less than x, less than 2 upon c. 2 upon c. Okay, so now we'll multiply by. So why we did this? So before that, okay, we'll multiply by c now. This, okay, we'll multiply by c. So here instead of this reciprocal we don't need. Okay, we'll multiply this c. Okay, c square by 2 cx. Why, that we'll see later on. This is by 2. Okay, we'll take a reciprocal of this one. If you take the reciprocal, then what? This is what, 3c square by 2 is less than 1 upon cx is less than c. You have to take the reciprocal. Okay, so you have to take the reciprocal, and the inequality will be reversed. That means what? So see, this is what you have to take the reciprocal. So this will what, 2 upon c square greater than 1 upon cx. 1 upon cx is greater than 2 upon 3c square. So that you may write this is what, 3c square less than 1 upon cx is less than 2 upon c square. Okay, we'll keep this as it is now. Okay, so now we'll take this one now. Mod of this we have given, this is provided to 1 upon c. Okay, so this is what, 1 upon x minus 1 upon c. 1 upon x minus 1 upon c. Okay, so now we simplify this. This is what, c minus x. C minus x upon cx now. Okay, so this is cx. For this cx we did this one. Okay, so this is what, then I can separate. I can write this is mod of x minus c upon mod of cx. Mod of cx. Now this c mod of cx is less than 2 upon c square. So this is what, this is less than mod of x minus c. 2 is c square now. If I multiply by mod of x minus c, mod of x minus c here, so it is what, 2 mod of x c square, and this is less than epsilon. This is less than epsilon. Okay, now see what we get now. So what we get then, mod of c, you get here mod of x minus c. That means in the f of x minus whatever this L, you have to find this x minus c now, and you have to show that x minus c is less than some number which contains epsilon. Okay, so this is what, then this is less than epsilon c square by 2. Okay, so now here we have taken that x minus c is less than c by 2. You have to take delta as minimum of c by 2 and this epsilon c square by 2. Okay, so I proved that there exists delta. So if you take the minimum of this one, if you take the minimum, that works now. So therefore for given epsilon greater than 0, there exists delta greater than 0 such that 0 less than mod of x minus c less than delta implies that mod of f of x minus 1 upon c is less than epsilon. So therefore limit x tends to c, f of x means 1 upon x is 1 upon c. So it is over now. Okay, we'll take the next one. We'll take next problem. Limit x tends to 2, x cube minus 4 upon x square plus 1 is equal to 4 by 5. 4 by 5. Okay, solution. We want to prove that limit x tends to 2, x cube minus 4, x square plus 1 is equal to 4 by 5. So here your f of x is x cube minus 4 upon x square plus 1. Okay. That is to prove that, for given epsilon greater than 0, there exists delta greater than 0, such that 0 less than mod of x minus 2 less than delta, implies that mod of f of x minus 4 by 5 less than epsilon. Okay, so before that we'll first simplify this, and then we'll take x minus 2, range of the x minus 2. First we'll simplify this. F of x minus 4 by 5, this is equal to, so what is that? X cube minus 4 upon x square plus 1 minus 4 by 5. So this is what is 5x cube minus 20 minus 4x square minus 4 upon 5x square plus 1. 5x square plus 1. Now here we want x minus 2 now. Okay, so we'll simplify this once again. This is what then 5x cube minus 4x square minus 24 upon, this is 5x square plus 1. Okay, now here I want a factor x minus 2. See, if you put x is equal to 2, here, so this is 8, this is what? 40. Okay, so then this will what? Minus 4, so this is 16 minus 24. Now see, this is 0. That means what here? X minus 2 is the factor. And that we want here. X minus 2 is factor. You have to find a second factor now. So there are two options. You have to divide this. And the remainder is 0. You have to find a quotient this. So divide this by x minus 2, find a quotient. Or another way is what? The simple another way. We will need only the second factor. So we'll try for this one. 5 minus 4, 0 minus 24. Okay. You know that 2 is the factor. We are taking 2 here. Okay. So this is 5. Know that this is the coefficient of x cube, x square, x and constant. Okay. You have to take the along with the sign. So last time you should get the 0. If we get the 0, then our method is correct now. This is what? 10. This is what then? 6. This is 12. This is 12 now. So this is what? 24. See here, 24. We get 0. That means we are correct. Now these are the factors now. This is what? 5x square plus 6x plus 12. Okay. Easily we got a factor with the synthetic division method. This is called the synthetic division method. Okay. No need to divide this. No need to divide by your usual method. Okay. So this is what, with the help of synthetic, we want only the quotient. We know that the remainder is 0 now. Okay. So here also you get the remainder. This will be the remainder when that is divided by this. Okay. So upon, see, we got this x square plus 1. Now we know that this is less than epsilon. Okay. So what we will do, we'll do this for, okay, so let x minus 2 is less than 1. We'll take the 1. Okay, and this is less than epsilon. We'll take a delta as that whatever the we get in terms of epsilon, and minimum of 1 is epsilon. So what is this then? This implies that minus 1 less than x minus 2 is less than 1. Okay, so this is less than 1. This implies that we'll add 2 now. So that we'll get the range of this one. This is what? 1 x less 3. Okay, so x less than 3 implies that, so see that this is 5x square plus 6x plus 12 is less than what? 5 into 3 square, 6 into 3 plus 12. Okay, so this implies that 5x square plus 6x plus 12 is less than, so what is this? 9. So this is what? 45, then 18 and then 12. Okay, so this is 30, this is 30, this is 75, this is what? 75. Okay, now x is greater than 1. x is greater than 1. Okay, so x square is greater than 1. X square is greater than 1. So x square plus 1, x square plus 1 is greater than x square plus 1. Now you are, the denominator is also there. Okay, so x square is greater. So x square plus 1 is greater than 2 now. X square plus 1 is greater than 2. So 1 upon, this is 1 upon x square plus 1 is greater than 1, is less than 1 half, is less than 1 half. And 5 is there, so we multiply this 5. So therefore what? 1 upon 5 x square plus 1 is less than 1 upon 10. Less than 1 upon 10. Now see. See, we have this. Now your 5x square. So therefore what? 5x square plus 6x plus 12 upon 5 into x square plus 1 is less than. See, this is less than 75. Your 5x square less than 75 and 1 upon this less than 1 by 10. So this is what? 75 upon 10. 75 upon 10. Okay, whatever this may be. If you want to simplify, it doesn't matter. Okay, now we multiply by x minus 2 now. X minus 2. So we'll take a mod of this x minus 2. Okay, so this is mod of this less than this. So mod, therefore mod of x minus 2 5x square plus 6x plus 12 upon 5x square plus 1 is less than 75 into divided by 5, then what we get? This is upon 2, then 15 mod of x minus c, mod of x minus 2, not x minus c, x minus 2, mod of x minus 2, and this is less than epsilon. This is less than epsilon. So therefore what? Mod of x minus 2 is less than twice epsilon by 15. Okay, twice epsilon. So take delta. Take delta is equal to minimum. Take delta is equal to minimum of so what we have taken? That is 1 and twice epsilon by 15. Okay, 1 and twice epsilon by 15. See, it is x minus 2. So how we got this x minus 2 is less than this? With the help of that f of x minus c less than epsilon. With the help of that one, we have proved that we got x minus 2 somewhere and it is less than this. Okay, so therefore for given epsilon greater than 0, there exists delta greater than 0 such that 0 less than mod of x minus 2 less than delta implies that mod of f of x minus 4 by 5 less than epsilon. Therefore limit x tends to 2, x cube minus 4 upon x square plus 4 is equal to 4 by 5. Right? So you have to do the practice on it so that the problem will be easy now. Okay, so we'll do one more problem. Limit x tends to 1, 3 by 2x minus 1 is equal to half. Solution. We want to prove that limit x tends to 1, 3 by 2x minus 1 is equal to half. So your f of x is what? 3 by 2x minus 1. Okay, that is, we want to prove that for given epsilon greater than 0, there exists delta greater than 0. Up to this is common to all now. Mod of x minus 1 less than delta implies that mod of f of x minus half now. is less than epsilon. This we have to prove. We have to prove this there exists delta. This delta is exist. Now with the help of this x minus f of x minus half, you have to less than epsilon. You have to convert this in terms of x minus 1 is less than some number. That you have to prove. Okay, that is the part. Okay, so find this f of x first, f of x minus half, and then we will rearrange the rearrange for x minus 1 then. Okay, so this is what then 3 by 2x minus 1 minus half. Okay, so this is what 3 by 2x minus 3 by 2 minus 3 by 2. So this I can take 3 by 2 common, we get x minus 1, and this is less than epsilon because this is what your f of x minus half, that is less than epsilon. So what we get then, mod of x minus 1 is less than epsilon upon is less than 2 epsilon upon 3. This is your delta now. This is your delta. Okay, so thus there exists, thus for given, automatically we get this, automatically we get x minus 1. Therefore for given epsilon greater than 0, there exists delta greater than 0 such that 0 less than mod of x minus 1 less than delta implies that mod of f of x minus half less than epsilon. So therefore limit x tends to 1, we will write that original function is equal to half. Okay, so now the problem is over here. Okay, we'll take the next one. We'll take the next one. If f of x is equal to x square 1, x not equal to 2, x is equal to 2, limit x tends to 2, f of x is equal to 4. F of x is equal to 4. This you have to prove. Okay, solution. Given that f of x is equal to x square, x not equal to 2, for x is equal to this is. Okay, so we want to prove that limit x tends to 2, f of x is equal to 2. That is to prove that or given epsilon greater than 0, there exists delta greater than 0 such that mod of x minus 2 less than delta implies that mod of f of x minus 4 less than epsilon. Okay, so first we will take mod of f of x minus 4 is equal to, we will simplify this and we will find x minus 2 somewhere now. So f of x is what? F of x is x square. See, x tends to 2 means it is in digital neighborhood, so you have to take the x square now. This is x square minus 4. So this is what? Mod of x minus, see we get x minus 2 here. Right? We get a x minus 2. This is your f of x. This is less than epsilon that we know. Okay. Now what we will assume that this is less than 1. Okay. Let mod of x minus 2 is less than 1. We will take this. This is our choice actually. We'll take and we'll take the minimum. We will show that this is what x minus 2 is less than. From this We'll show that that is less than this. So why we did this? This for only for this x plus 2. We want to remove the x plus 2 now. So what does this imply then? Minus 1 less than x minus 2 less than 1. So this implies that 1 less than x less than 3 now, and x less than 3. So therefore mod of x plus 2 is less than mod of x plus 2 is less than 5. So therefore mod of x plus 2 x minus 2 is less than 5 into mod of x minus 2. 5 into mod of x minus 2. Right? So therefore what? Therefore mod of f of x minus 4 is less than 5 mod of x minus 2, and this is less than epsilon. Your mod of f of x less than epsilon. So therefore mod of x minus 2 less than epsilon by 5. So take delta is equal to minimum of 1 and epsilon 5. Okay. So epsilon by 5. So therefore for given epsilon greater than 0, there exists delta greater than 0 such that 0 less than mod of x minus 2 less than delta implies that mod of f of x minus 4 less than epsilon. Therefore limit x tends to 2, f of x is equal to 4. So we have proved. Okay. Now we'll take another problem. So that the idea will be clear to you now. Limit x tends to 1, x square plus 1 is equal to 2. We'll take the second one. Limit x tends to minus 1, x plus 4 upon twice x plus 3 is equal to 4. Third one, limit x tends to 2, x square minus 4 upon x minus 2 is equal to 4. Okay, so we'll solve these three problems. Okay, solution of first one. We want to show that or prove that limit x tends to 1, x square plus 1, okay, x square plus 1 is equal to 2. Okay. That is to prove that. So here f of x is what? Here f of x is x square plus 1. Okay. That is to show that you are saying that, so we'll say, if you are saying that prove that, we'll prove. That is to show that for given epsilon greater than 0, there exists delta greater than 0 such that 0 less than mod of x minus 1 less than delta implies that mod of f of x minus, what is the value of the limit? Value of the limit is 2 less than epsilon. Okay, so this is given to you. We want to prove that this is x minus 1 is less than, with the help of this one we have to prove that x minus 1 is less than some number. That is our aim now. Okay, so we'll do this is mod of x f of x minus 2. So this is what then mod of f of, what is your f of x is x square plus 1 minus 2. So this is what x square minus 1, and this is nothing but mod of x plus, see you got here x minus 1. If you don't get x minus 1, then there is a mistake. So you have to check this once again. So check your calculation once again. Okay. So now we got this. Naturally we got this x minus 1 there. So now this is less than epsilon is not doing. Okay. So what we'll do? We'll take. Okay. So let mod of x minus 1 is less than 1. Okay. We'll take the minimum of 1 and okay. So this implies that minus 1 less than x less than 1. So this implies that x minus 1. 0 less than x less than 2 now. Your x less than 2. So therefore x plus 1 is less than 3 now. Okay. So therefore mod of x plus 1 into x minus 1 is less than 3 into mod of x minus 1. Okay. Now see, you got this term here now. But what is this? This is f of x minus 2. What is this f of x minus 2? Is less than epsilon. So this is less than epsilon. This, see, you got this here. This is less than epsilon. This is less than epsilon. Okay. So therefore, you see, you got here now. Therefore, what? Mod of x minus 1 is less than epsilon by 3. Okay. So we'll take delta is equal to minimum of 1 and this epsilon by 3. It will work. So we have proved that there exists delta greater than 0. So thus for given epsilon greater than 0, there exists delta greater than 0 such that we have proved that 0 less than mod of x minus 1 less than delta implies that mod of f of x minus 2 less than epsilon. So therefore, limit x tends to 1. What is your x? F of x will write original function. The limit is 2. Okay. So the first part is over. Okay. Now second one. We'll take the second problem. Limit x tends to minus 1. Here you want to minus 1 x plus 4 upon twice x plus 3. Is it correct? I think the problem is wrong here. So x minus 1, it should be 5. No, this should be the 5. Okay, so this is 5. This is 5. Because if you put x is equal to minus 1 plus 5 is the 4 now. Okay, it will be not, it will be what? So if it is 4, then it will be 3 now. So there is the printing mistake. Okay, no problem. Okay, so f of x is what? X plus 5 upon twice x plus 3. This is your function. Okay, so that is to show that for given epsilon greater than 0, there exists delta greater than 0 such that 0 less than mod of x minus become plus 1 now less than delta implies that mod of f of x minus 4 is less than epsilon. Okay, so first we will simplify this and then we will see what we want, how to arrange that x, that we will see. First we will simplify this. This is what? X plus 5 upon twice x plus 3 minus 4. So this is what then? X plus 5 minus 8x minus 12. Here I want x plus 1. Here I want x plus 1. Twice x plus 3. Twice x plus 3. So this is equal to what then? This is equal to x, this is 7x minus 7x minus 12. So minus 7 upon twice x plus 3. So this is nothing but what? 7x plus 1 upon twice x plus 3. Okay, so I want, this is less than epsilon, I want, okay, that. So I don't want this twice x plus 3 and so on. Okay, so what I do? So therefore I will take let mod of x minus, so x plus 1, right? Mod of x plus 1 is less than 1. Okay, so this implies that minus 1 less than x less than x plus 1. Here x plus 1 is less than 1. Okay, I will subtract this. So this is minus 2 less than x is less than 0 now. Is less than 0. So x plus 5 upon 3. So what I got? So instead of that I will take 1 by 4 now, because I got the negative number here. So I will take 1 by 4. I will take 1 by 4. Because I don't want that negative number. I want that number as a positive. So I will take 1 by 4. Doesn't matter. So 1 by 4. Okay. We will take 1 by 4. Less than this. Okay. So because there is a plus 1. So we have taken this is less than, this is minus 1 actually. Okay. So we'll take this one. So what we get then? Minus 1 by 4 less than x plus 1 less than 1 by 4. Okay. So this implies that minus 1 by 4. So this is what? Minus 1 by 4 less than x plus 1 less than 1 plus minus 1 plus 1 by 4. This implies that minus 5 by 4 less than x plus, not x plus 1. So 1 is not there. Less than minus 1. So minus 3 plus 1 minus 4, that is minus 3 upon 4. So this is okay. So therefore x is greater than minus 5 by 4. So therefore I want this twice x plus 3. I want that twice x plus 3. So that because we have to take the reciprocal, we want less than, we want that less than. So we'll take a greater, x is greater than. So first what we'll do, we'll multiply by 2 now. So twice x is greater than minus 5 by 2 now. We'll add 3 now. So twice x plus 3 is greater than minus 5 by 2 plus 3. So therefore twice x plus 3 is greater than, so 1 by 2. This is 1 by 2. See, we get a positive number here. We get a positive number because this is now your twice x plus 3 is positive. So mod of twice x plus 3 will be the twice x plus 3. Okay, we'll take the reciprocal of that one. So this is what? Twice x plus 3 is less than 2 now. Is less than 2. Okay, so this is less than 2. So now what we will do? We will multiply by x plus 1 now. Okay, so 7 into, so we'll directly write this what? So therefore mod of 7 into x plus 1 twice x plus 3 is less than or equal to, what we got? The 7 mod of x plus 1, because 7 is positive, upon this twice x plus 3 is 2. So this is 14 now. This is what? 14 mod of x plus 1. Now what is this? This is 7x into this is your f of x minus 4, and this is less than epsilon. So therefore mod of x plus 1 is less than epsilon by 14. So therefore what? Take delta is equal to minimum of, what we have taken? X plus 1 is 1 by 4. So you have taken 1 by 4. This. Okay. So it work now. This work. So that means what? This delta x is minimum of this or this. We want to show that there exists. Okay. So I proved that there exists a delta. This is what? Minimum of this one of this. Okay. So thus, so this we want to prove only. There exists delta. This is our aim. To show that the delta is exists. This is our aim. So therefore, for given epsilon greater than 0, there exists delta greater than 0 such that 0 less than mod of x plus 1 is less than delta, implies that mod of f of x minus, what is the value of the limit? What is the value of the limit? 4 is less than epsilon. So therefore limit x tends to minus 1, f of x is equal to 4. Okay, so this is the solution. Okay, we'll take the next one now. Last one is the third. Okay, solution of third now here. So actually what? The mod of x minus 1, we have to take the 1 by 4. That part was the crucial part, because what? Everywhere we have taken the 1. Okay, so for x minus 1, so I have taken that 1 by 4, so that we will get a So that is the important here. Okay, we want to show that limit x tends to 2, x square minus 4 upon x minus 2 is equal to 4. So f of x is equal to x square minus 4 upon x minus 2. That is to show that for given epsilon greater than 0, there exists delta greater than 0 such that 0 less than mod of x minus 2 is less than delta, implies that mod of f of x minus 4 is less than epsilon. So we start from f of x minus 4 and then we will rearrange our mod of x minus 2. Okay. So what is this? This is equal to x square minus 4 upon x minus 2 minus 4. So this is equal to, so x square minus 4 minus 4x plus 8 upon x minus 2 upon x minus 2 upon x minus 2. So what is that? So this is same as what? X square minus 4x plus 4 upon x minus 2 upon x minus 2. So this is nothing but x minus 2 square upon x minus 2, and this is nothing but x minus 2. This is nothing but, directly we get x minus 2 now. Directly we get x minus 2. Okay. This is and this is less than epsilon. So this is your delta now. Delta. So your delta is what? Epsilon. Take delta. Here what? X minus 2 is less than epsilon. So that you can take delta. So therefore, for given epsilon greater than 0, there exists delta greater than 0 such that we can directly write such that this. So instead of show that, therefore we can write. Okay. So this you can write. So therefore, limit x tends to 2, f of x is equal to 4. Just problem is over. Very simple problem, because we got x minus 2. Okay. So we'll take the next problems and then we'll stop here. Okay. Limit x tends to 2. Limit x tends to 2. 1 upon 1 minus x is equal to minus 1. Second, limit x tends to 1, x square minus x plus 1 upon x plus 1 is equal to half. Limit x tends to 3, twice x plus 3 upon 4x minus 9 is equal to 3. Limit x tends to 6, x square minus 3x upon x plus 3 is equal to 2, and limit x tends to 0, x square upon mod x is equal to 0. Okay, so we'll take these problems. We'll take this problem. Okay, solution 1. Limit x tends to 1 upon 1 minus x is equal to minus 1. This we want to prove that. Okay, so here f of x 1 upon 1 minus x. Okay, so now we want to show that there is for given epsilon greater than 0, there exists delta greater than 0 such that 0 less than mod of x minus 1 is less than delta, implies that mod of f of x minus minus 1 become plus 1 is less than epsilon. Okay, so we start from f of x minus 1 now, f of x plus 1 now. What is your f of x? 1 upon 1 minus x plus 1. So this is what then this is what 1 plus 1 minus x, 1 plus 1 minus x upon upon 1 minus x. So this is what we can write, this is mod of x minus 2 upon x minus 1. Okay, no problem for this one. So this is what then, this is 2 minus x, 2 minus x upon 1 minus x. So I can write this is what x minus 2 upon x minus 1. I can change the sign of all terms. Okay, x minus 2. So see, you got x minus 2 now. Okay, so x minus 2 mod of x minus 2 is less than 1. Suppose this is less than 1. What does this imply then? This implies that minus 1 less than x minus 2 is less than 1. Okay, this implies that 1 less than x less than 3 now, less than 3. So your x is greater than 1. Your x is greater than 1. X is greater than 1. Okay. So for that, what we will do? We take the next number, because what we get x minus 1, we get x minus 1 is 0, and we don't get any number, so we'll change that. We will change that. So instead of 1, we'll take half now. Instead of this, we'll take half. So this is minus half. This is half now. And if you add 2, then what we get here? See, if you get what x greater than x minus 1 is 0 now. It do not work now. So there should be the number now. Okay. So therefore we will have to change our direction now. So we'll take that minus half. We'll add this 2. So 2 minus half. 2 minus half is 3 by 2. 2 minus half is 3 by 2. So this is what? 3 by 2 less than x less than 5 by 2. Okay. Now this works now here. What? X is, because this is 1 upon x minus 1 we have to do. So this is what? X is greater than 3 by 2. Okay. Now x minus 1. X minus 1 is greater than 1 half now. 3 by 2 minus 1 is half. Now then 1 upon x minus 1 is less than 2. Is less than 2. So both are the positive now here. 2 is positive here. Okay. You got this. So we multiply by now x minus 2. Okay. So therefore mod of x minus 2 upon x minus 1 is less than 2 into mod of x minus 2. Okay, just I have multiplied here what? X minus 2. Just I have multiplied here x minus 2. Okay, so therefore what? Therefore therefore 2 into mod of x minus 2 less than epsilon. Okay, so mod of x minus 2 is less than epsilon by 2. So take delta is equal to minimum of half. We have taken that x minus 2 as half now. Half epsilon by 2. Only we have to prove that there exists delta. So I have proved that there is delta, either this or this. Okay. Okay. So therefore for given epsilon greater than 0, there exists delta greater than 0 such that 0 less than mod of x minus 2 less than delta implies that mod of f of x plus 1 less than epsilon. So therefore limit x tends to 2, f of x is equal to minus 1. So we have proved. We'll do for the next one, second one. We want to prove that this is common to all now. Limit x tends to 1, x square minus x plus 1 upon x plus 1 is equal to 1 half. So here your f of x is x square minus x upon x plus 1. Okay. So that is to prove that, that is to prove that Here we are saying that prove that, so say prove that. So if you are saying that this is show that, it's show that. We want to prove that for given epsilon greater than 0, there exists delta greater than 0 such that 0 less than mod of x minus. So we are taking the second problem. Okay, this problem we are taking. Okay, x minus 1 less than delta implies that mod of f of x minus half now less than epsilon. We will simplify this. With the help of this one, you got x minus 1 is less than some in terms of epsilon. That we want. That is our aim now. Okay. So now we'll take a mod of x minus half. Mod of f of x minus half. This is equal to x square minus x plus 1 upon x plus 1 minus half. We'll simplify this. So this will what? Twice x square minus twice x plus 2 minus x minus 1 upon x plus 1 upon x plus 1. So this is what then? This is twice x square minus 3x plus 1 upon x plus 1 upon x plus 1. I want x minus 1 as a factor. So if you put x is equal to minus 1, see this is what? 2. This is 2. We are putting minus 1. So plus you are putting x. You want x minus 1 as a factor. If you put x is equal to 1 here, it is 0. That means it is a factor. You have to find the second factor. Easily you can find the second factor by synthetic division method. So this is 1. Okay. So you want to prove that x plus 1, x minus 1 is a factor. So write here 1. This is 2, minus 1. So this is 0. Okay. So what are the factors? Factors are x minus 1 into x minus 1 into twice x minus 1 upon x plus 1 upon x plus 1. Okay. So now see, you got x minus 1 here. Now we are interested in twice x minus 1, x plus 1. We'll prove twice x minus 1 and x plus 1 is less than some number, and then we'll multiply by x minus 1. Okay. So for that what we'll do, we'll take mod of x minus 1 is less than, if you take the 1, we get 0 now. So we are not taking 1 now, we are taking half now. Okay. So what does this imply then? This implies that minus half less than x minus 1 is less than 1 half. And this implies that what is the range of x now here? So you have to add 1. Then this is what? Half is less than half is 3 by 2. Okay. So first we will take x 3 by 2. X is less than 3 by 2. Imply that. So we'll make twice x minus 1 now. With that twice x minus 1. So this is twice x is less than 3. This implies that twice x minus 1 is less than 2 now. Your twice x minus 1. See, you got twice x minus 1. This is less than 2. Now we'll do 1 upon x plus 1 now. So now x is greater than half. Imply that you want x plus 1 now. So x plus 1 is greater than 3 by 2. Okay. So you are adding 1. So this implies that 1 upon x plus 1 is less than 2 by 3 now. Is 2 by 3. So we do this product. So therefore, twice x minus 1 upon x plus 1 is less than 4 by 3. Okay. See, you got this. This is f of x minus n. Twice x minus 1 upon x plus 1. Just we multiply this. So therefore, this is less than. This is just we are multiplying by x minus 1 now. We have to multiply only x minus 1. This is multiplied by 4 by 3 mod of x minus 1. Just multiply this. Okay? And this is less than epsilon. This is less than epsilon. So therefore, mod of x minus 1 is less than 3 epsilon by 4. So take delta is equal to minimum of half 3 epsilon by 4. 3 epsilon by 4. Okay. So I hope that idea is clear. So we have proved that there exists delta, right? So therefore what? Therefore for given epsilon greater than 0, there exists delta greater than 0 such that 0 less than mod of x minus 1 less than delta implies that mod of f of x minus half less than epsilon. So therefore limit x tends to 1, f of x is equal to half. So I proved this. So I hope that you can solve the rest of the problem. I hope that you can solve the rest of the problem. So now we'll stop here. Thank you.